Right. In this lesson, we shall actually be looking at Euclidean geometry. O is the center of the circle. KOM bisects chord LN. So you have that KOM bisects the chord LN, and the angle MNO is 26 degrees, and we can see 26 degrees here, MNO. K and P are points on the circle with NKP equals 32 degrees. We can see that here OP is drawn, and there is OP. Determine giving reasons the size of the angle O2, and we were able to analyze that obviously earlier on, and we're able to see that the angle O2 is 2 times the angle of 32 degrees, and this is exactly 64 degrees there. And the reason for that is that angle at center, right, angle at center, I'm recapping please quickly, is equal to 2 times angle at circumference. Okay, now this is awesome news. Then what do we do? Angle O1. Right, now to find the size of angle O1, we went on to do the following thing. Right, so to find the angle O1, we actually proceeded as follows, and we said that this one you already know is 64 degrees, and we just need to deal with the whole angle here. We started by saying now to deal with the angle, the question 8.1.1, but the part B part, and we're to find the size of the angle O1. We first noted that the angle M2 is equal to 90 degrees. Okay, and this angle M2 here is equal to 90 degrees. We're to find the angle O1. And why? This is because you have the line from center to midpoint of chord. Line from center to midpoint of chord. So that in the end, right now, you actually need to do O1, O2, which is 90 degrees plus 26 degrees. Right, and then 90 plus 26 is 116 degrees. And the reason for this is that is the grade 10 reason. Okay, we have the exterior angle. The exterior angle of triangle. Okay, grade 10. And then now we actually obviously got the implication that this is angle O1 plus angle O2 is 116 degrees. But moreover, we have that angle O2 already is 64 degrees, so that we have O1 plus 64 degrees, which is 116 degrees, which means that angle O1 is 116 degrees minus 64 degrees. And this is 52 degrees, meaning angle O1 is 52 degrees, like this. Okay, so these are the kinds of things that you need to note, meaning the angle O1 here is actually 52 degrees. This one here. And the other angle that we've already got the angle O2, and the angle O2, we got it to be 64 degrees. And then in the next thing, we got this one to be 64 degrees, angle O2, and we got angle O1 to be 52 degrees, this one here. And then it remains for us to find the size to do this one, to prove this question. Proof giving reasons that Kn, right, so you have that Kn bisects angle OKP, right, so Kn bisects angle OKP, so that in the end, then what we then have is that we can note that if you add all these angles in the triangle, so you can, in your attempt to do 8.1.2, you can tell the examiner that in triangle KON, right, in triangle KON, you add everything. So you add angle K2 plus the 52 degrees, but you also add the 64 degrees. You also add this angle here. What is this angle here? This angle here is the KNO. You add K and O, and the result must be 180 degrees. Okay, and now, why is this the case? And to give a justification for this, the reason you state is that you have the sum of angles in triangle. So that the angle K2 plus KNO is then equal to 180 degrees minus these two guys. These two guys, if you add 52 and 64, we get 116 degrees. We saw that one. And this is K2 and this is KNO. Right, so that this is actually exactly 64 degrees. We saw that earlier on. And we went on to then say, but, okay, obviously this one we agree together is KNO because it's just a quick recap. I'm just trying to make sure that because my recording runs from the beginning of the lesson to the end. But now you have that the angle K2 is equal to, because of this radius is equal to the radius here. So the angle K2 is equal to KNO. And this is true. And because this is true, why is this true? It is true because of angles opposite equal sides. Okay, we have a tendency of saying that one. And we're saying angles opposite equal sides. If you don't want to say this, what you then say is OK equals ON radii, like this. Okay. So that in the end, then what you have is K2 plus. Now the KNO is also K2, which is 64 degrees. What is K2 plus K2? It is 2K2 equals 64 degrees. And you divide by 2, which means that K2 is equal to 32 degrees. Okay. So you have that the angle K2 here is 32 degrees, like that. So because of this, because K2 is 32, it then means that K1, so you can write a conclusion here. Therefore, angle K1 is equals to angle K2. Therefore, angle K1 equals angle K2. Because angle K1 equals angle K2, so this is equal to angle K2, and they're both equal to 32 degrees. And the conclusion, therefore, is that Kn bisects OKP, angle OKP, right? So the conclusion is therefore that Kn bisects this Kn here, K to N bisects OKP. Right, next question is to look at the question we're looking at to see. Okay, yeah, it's a new question, this one. So in triangle ABC, I need your full attention here because this is very important. F and G are points on the sides. Now, F and G are points on the sides of AB and AC respectively. D is a point on GC. D is a point on GC such that the angle D1 is equals to angle B. So angle D1 equals to angle B. If AF is a tangent to the circle passing through points F, G, and D, then prove giving reasons that FG is parallel to BC. Right, so now we are told that if AF is a tangent, right, so AF is a tangent, being a tangent to the circle that passes through F, G, and D. There's a circle that is going to pass through F, G, and D. So the circle is going to be like this, through F, G, and also D. Okay, it looks like that, and this AF is a tangent. Okay, like this. This AF is a tangent. Then here comes the questions. And then now the examiner is then saying, obviously, proof giving reasons that FG is parallel to BC. You want to prove that FG is parallel to BC. FG is parallel to BC. Okay, if this is drawn and this is a tangent to the circle, now it means the angle between a tangent to the circle and a chord equals the angle that is subtended by this chord. This is the angle here. So first things first, to do 8.2.1, this is the answer. Right, so now using the technical theorem, what do we do in 8.2.1? We need to first say angle F1 is equal to angle D1 and is the 10 chord theorem. Right, so angle F1 is equal to angle D1, which is the 10 chord theorem. Okay, F1 is equal to the angle D1. Then from there, you come and then say, the angle D1 is B. The angle D1, this one here, is equal to the angle B. Why is this the case? Why is angle D1 equals to angle B? Because this one is given. It's given. You're given that angle D1 is equal to angle what? Angle B. Okay, if F1 is D1 and D1 is B, the conclusion, therefore, is that angle F1 is equals to angle B, like that. So angle F1 is equals to angle, F1 is equal to angle B. So now we're back to grade 10. If you have something like this angle is equal to this, then what can you say about these two lines here? So if this angle, you have this angle is equal to this, because we're saying F1 is B. So then the conclusion, therefore, is that FG must be parallel to BC. FG must be parallel to BC. And the reason for this is that we have the corresponding angles equal. Right, so why is FG parallel to BC? Because the corresponding angles are equal. So these two take the position or the positions of what we call corresponding angles. Okay, so we have that one. So we're able to then prove that if AF is a tangent, to the circle passing through F, G, and D, then proof giving reasons that FG is parallel to BC. So we've proven that FG is parallel to BC. Okay, we have that one. So we're looking at 8.2.2. We're looking at 8.2.2. Now, to deal with 8.2.2, it is this one. If it is further given that AF over FB is 2 out of 5, AF over FB. So if AF over FB is 2 out of 5, we can call this one 2P and 5 and 5P. Right, so you continue quickly. We continue quickly. So which means it's 2P over 5P. So now, which means it's AF over FB. So it is 2P over 5P. Okay, 2P over, you can just put a letter here like this, so that you have that ratio there. Okay, and then now, we have also been given that AC is 2x minus 6. And then also GC is x plus 9. X plus 9 is overall GC. And then you have the AC. The AC is 2x minus 6. Right, then calculate the value of x. Right, so to find the value of x, there are a couple of things that are very important here. We need to find the value of x, and there are a couple of ways to do this. So now we're gonna use a theorem here to find the answer. So you can use the fact that at this point, because we want to find the value of x, you can come here and use the fact that you already know something. You already know that FG is parallel to BC. So FG is parallel to BC. So that you come and say GC over, right, so you're going to do GC over AC. Right, so GC over AC is equal to FB over. And then now you're looking at the AC, and then it's going to be AB. Right. And so because of this, now, why is this the case? So you're taking GC over AC is equal to FB over AB. Right. And the reason for that is we say line parallel one side of triangle. Line parallel one side of triangle. What is GC? X plus 9. What is AC? AC, 2x minus 6. And then what is FB? FB is 5p. What is AB? AB is 7p. Okay, from A to B, it's 7p. So you cancel everything here. So this is exactly x plus 9. You divide by 2x minus 6. And this is 5 out of 7. Okay, you cross multiply here. Cross multiplication, which is exactly, if you do cross multiplication, this is going to become 7 times x plus 9 is 5 times 2x minus 6. And this is exactly 7x plus 7 by 9 is 63, which is equal to 5 times 2x is 10x minus 30. So that we have 10x minus 7x. 10x minus 7x is what? Is 3x. And then we have 63 plus 30, which is 93. You divide by 3 so that you have 31 is equal to x. Okay, so with 31 is equal to x. Now, look at this here. We have 31 is equal to x. Now, note that this is very, very important. So if 31 is equal to x, then we have this, and we have found that x is equal to 31. And obviously, the question was calculate the value of x, and we found x to be 31. So we have answered question 8.2.2, and then we proceed to the next question. All right, if you have a question, please, you're always welcome to ask. If you are confused somewhere, please ask, and then we can answer. Right, the most famous theorem called the 10-chord theorem is to be proven right now. And we shall look at the methods we can use to prove this particular theorem. So in the diagram, O is the center of the circle. Here is O as the center of the circle. Points S, T, and R. S, T, and R lie on the circle. Chords ST and SR and TR are drawn in the circle. QS is a tangent to the circle at S. QS is a tangent to the circle at S. Use the diagram to prove the theorem, which states that QST is R. QST is R. So now we have QST is R. So you need to prove that QST is R. So how do you prove this? Right, there are a couple of things that we need to consider to actually prove this particular result here. First things first, we perform a construction. We perform a construction. By performing a construction, what do? We actually draw diameter KS, and draw KR. So that in the end, then you have this here. So that in the end, then you call this K. You call this point K. And then now we're going to start by saying the angle, for example, the angle QST. QST is equal to what? So the angle QST plus the angle TSK is equal to 90 degrees. So we start QST, angle QST plus the angle TSK is 90 degrees. Why? Because a radius is always perpendicular to a tangent. Because this one is through the center, so it's a radius, it is perpendicular to a tangent. So when we add this angle here, the QST, and then we add the TSK, the answer is exactly 90 degrees there. And as a consequence, then you have QST, which is equal to, if you move the TSK across, you have 90 degrees minus TSK, like this. So that now you have the SRK, the angle SRK, because this one is a diameter. A diameter in mathematics at grade 11, a diameter is the grade 11 theorem. A diameter subtends an angle of 90 degrees at circumference. It's called the angle in semicircle theorem. So that in the end, then you have that the SRK, angle SRK, right? The SRK is equal to 90 degrees. The SRK is equal to 90 degrees. Why is that the case? Because it is an angle in semicircle. Angle in semicircle. Right. So if that is the case, then what do we then do? We continue to then engage with this. And we continue to realize that therefore the angle SRT, let's look at the angle SRT. Right. Looking at the angle SRT, which is the angle we want, is then equal to what? This angle. Right, the angle SRT is then equal to 90 degrees minus KRT. So this angle SRT is the whole of this 90, minus KRT. We just subtract the top here. So if you take the whole 90, and then you remove this part, you minus KRT, you will get the bottom angle here, which is SRT. Hey, right, this is geometry for you. Make sure you're attentive because I'm going to give you tests on WhatsApp. Okay, and then you're going to submit the tests. You're going to send me the tests during the week. And then I'm going to mark and I'm going to give you marks. So I'm going to give lots of tests on geometry on WhatsApp. So please get ready. So at this point now you have this. And what is this here? We notice that the angle TSK, right, the angle TSK is equal to the angle TRK. The angle TSK is equal to the angle TRK. And these are angles in same segment. Angles in same segment. So that then in the end, what do we then have here? So what we're having then is that in the place of the angle, you can put TSK here in the place of KRT. So we can then say, therefore, angle SRT is equal to 90 degrees minus the KRT. So the KRT is the same as TRK. So you put here TSK. You put here TSK. Because the TSK is equal to, now you come here again, TSK is this angle here. So TSK is equals to TRK. TRK. These are the bow tie angles. Okay, angles in the same segment. These, okay? So, and you can always draw the angles in the same segment. How do you see angles in the same segment? Because some of you are still learning this geometry. Angles in the same segment, you see them like in a diagram like this. These are angles in the same segment. The angle star is equal to the angle star. Dot equals dot. Okay, good. Now we continue. Right, so we're in business and this is what we have. And what do we then say? Okay, we just performed the substitution. This is the reason would be substitution here, but that's a very trivial reason to state. Now, what is the next thing that we can then say out of this? Okay, look, because we already have that, so we're going to do this. This one. This particular statement here, or this equation, and this particular equation here. Okay, this particular equation, it's 90 degrees minus TSK, 90 degrees minus TSK, which means therefore we can put a conclusion that the angle QST is equal to SRT, angle SRT, because they are both equal to 90. This one is 90 degrees minus TSK, 90 degrees minus TSK. So 90 degrees minus TSK, 90 degrees minus TSK, meaning this QST is equal to SRT. And obviously, I mean, it means that the QST is equal to angle R, which means that the QST is equal to angle R. So that we have that the angle QST equals to angle R. And this is what we have to prove here, right? And this theorem here is not foreign to us. It is called the 10-chord theorem. So it's not as strange as these. They're asking you to prove this one. So this is the proof. What we've presented here is the proof. It's a proof of this because there are many proofs. There are many ways to prove this, but this is the most recommended method at grade 11 and in the matric syllabus, that you prove it like this. So you follow these steps of reasoning. They're going to ask you in June, because in the June exam that you're going to write, that you're going to use to even apply to university, it's going to be there, this question. They're going to ask you to prove this, and this is how you need to prove it, because your teachers are doing this in school now, and then you're going to be moving to analytical geometry also, and doing the calculations, the midpoints, and the distances and things. Okay, let's continue. All right, I believe there's no question here from anybody. Right, there's another question like this that comes most of the time in the syllabus at grade 11 and also at grade 12. Now, chord QN, right? Chord QN, here is Q and N, and this is a chord bisects M and P. This M and P, and this chord QN bisects. What does it mean to say this chord bisects? If we have this angle MNP, which is bisected by the chord QN, it means that this chord cuts the angle into two equal parts, and hence the word bisect is to divide into two equal parts, right? And intersects chord MP at S, chord MP at S. The tangent at P meets MN produced. The tangent at P meets MN produced at R. Right, the tangent at P meets MN, here is MN produced at R. So in other words, they're dealing with a tangent here. So this one is a tangent, okay? Right, such that QN is parallel to PR. Let's just check that one. So we have QN is parallel to PR. So you can have all sorts of alternate angles and very good things here that will come out of the fact that you have parallel lines here. But angle P1 is X, okay? The examiner just gave it as X. Now they're saying determine the following angles in terms of X. Give reasons. What is the size of the angle N2 in terms of X? Where is N2? Right, this is N. And this is N2. What is the size of the angle N2 in terms of X? Okay, we are back to grade 6 or grade 4. These angles in Z, what do you call these angles in Z? So that this one is equal to this. These are the alternate angles. So that if this one is x, this one is also x. So that the angle N2 is equal to x. Why is the angle N2 equal to x? It is equal to x because of the alternate angles. If you have alternate angles, tell the examiner which lines are parallel, okay? The examiner was good enough to tell us, okay, it has to do with the Q and the N. So you have QN, and then it has to do with this line, which is the P and the R. So in other words, you have QN is parallel to PR. Okay, so what is Q2? What is angle Q2? Right, so the angle Q2, for instance, is this one. Right, and now we need to find the angle Q2 in terms of x. Anyone who can find the angle Q2 in terms of x? Anybody home? Quickly answer. What is the angle Q2? This one in terms of x. Who can find it? You can't talk. You don't know how to talk. You don't know how to talk. This is the angle Q2. Want to find this one? What is the size of this one in terms of x? Hey! Who is here? Who is not here? You don't know. Okay, never mind. Right, if you have, because you already have a tangent here. You're told that a tangent at P, so you have a tangent at P. This at P is a tangent. So if you have a tangent, then you have a triangle like this. Then the angle here must be the angle between a tangent to a circle and a chord equals the one subtended by this chord, and this chord subtends this angle here so that this equals this. Also, you can say this one equals this. Okay, so that in the end, then you have this kind of a diagram, but it appears in the exam question like this, and then you have this, right? So that this angle here is equal to the angle subtended by this chord here, and this chord subtends this angle, which is x, which means that the angle Q2 is what? Is x. And why is the angle Q2 equal to x? The angle Q2 is equal to x because of a couple of things. It is the angle Q2 is equal to x because of the 10 chord theorem. Right, so you say the 10 chord theorem. 10 chord theorem. Right, the 10 chord theorem, like this. Okay, now let us continue. Okay, the 10 chord theorem. Yes, please.
Can I ask?
Yes, please.
Wrong if I'm wrong if I said erasing its external angle of a triangle.
If you say exterior angle of triangle,
Yes.
obviously you have to be specific in terms of the exterior angle of triangle, because exterior angle, I get your point. If we're in grade 10, then you have A, B, C, and then you can put 2, 1. Yeah, okay. Right, I'm trying to actually bring that theorem from grade 10 because it's done at grade 10, that theorem. So that now you come and say angle C1 is equal to angle A plus B. Okay, it's exterior angle of triangle. Okay, but the exterior angle of triangle is going to occur when this line is straight. But you see now, it could be exterior angle of triangle if this one was straight. From here, straight like this. Then it could be exterior angle of triangle. It could be this is equal to this plus this, because the exterior is equal to the sum of the interior opposite. You know? But because now this chord is not straight, it's just a tangent that's there, so it's bent. See, this must be straight, must be a side that is like produced for the exterior angle to be formed. Because if they draw something like this in the exam, then it's not an exterior angle anymore. You get the point? Okay, right, let's look at the next,
Yes.
let's look at the next thing. Okay, I want us to look at 9.2.2. Let's look at 9.2.2. Okay, now we want to look at 9.2.2, proof giving reasons that, okay, now we are from the previous thing, but yeah, we know that this angle is equal to this because the QN, this QN bisects this angle here. And then we know some of the things, like we know that this one is X. Okay, these things that come from the previous questions, they are there not as a decoration, they are there to help you because they're gonna apply here. And then now when they apply here, they will need like more steps, okay? And now we already know that this N2 is also X, and this Q2 is also X, but this N1, because N1 and N2 are equal to each other. So if this N2 is X, this one is also X. Okay, we're just writing those notes here. Obviously, the examiner is asking us to prove this. So to prove this one right now, the examiner is dealing with the M what? Mn over Nr. Is dealing with Mn over Nr. And then also is saying it is equal to ms. And then instead of saying ms over, because now it's bringing this theorem that this triangle here. Okay, and this is the theorem we learn. What is this theorem? Okay, I'm just going to draw it here. Just a small baby triangle here. Okay, if you draw this and you do this, and then now you do A, B, C, and then you do D, E. What is the theorem, proportionality theorem saying here? The proportionality theorem is going to say here, for instance, CD over DA is equal to CE over EB. Okay, this is the theorem that we're going to use here, because you have some parallel lines, but this triangle has been rotated. Now it's looking like this, you know? And then now, why do you say this? Why are we saying these things here? Why are we just dividing these sides? We're dividing them. And the reason is we always do this division because of a consequence of the proportionality theorem. And we actually state that it is the proportionality theorem. And the reason in this case, for instance, you could say from this triangle here, from the theorem we do, it is DE. DE, the reason for this dividing the ratios like this and then forming proportions is to say DE is parallel to what? Is parallel to AB. Why? Proportionality theorem. Proportionality theorem. Okay, now this is what you have. But now we need to use this theorem to do this. Okay, so let us do 9.2.2. If we know we can do it with one triangle like this, now they've put this one in a circle. But now we're going to come to the examiner and say, Mr. Examiner, what we know is that MN, right? MN over NR is equal to MS over SP. Y, which is QN, right? Which means, therefore, why is this the case? Okay, we've taken MN over NR is equal to MS over SP. Okay, this is, we're using this triangle here, the one I've marked in red with this, so that it looks like this. But now this is done because the QN is parallel to what? The QN is parallel to PR. QN is parallel to PR, and this is the proportionality theorem. Right, this is the proportionality theorem. So that in the end, then we have this, but we don't want to prove this only. We need MN and R, MS, and then we must just have this. Here the examiner has just put SQ. We must prove that this SP is equal to SQ. So to prove this one, we make a couple of notes to prove that this SP is equal to SQ. To prove that SP is equal to SQ, you'd have to establish that this angle P3 is equal to, you have to show that this angle P3 is equal to X, but yeah, we don't know yet, but you need to show that this angle P3 is equal to X. So, but obviously you are able to see that it is equal to X because let's start by saying angle N1, just pay attention. Angle N1 is equal to angle N2 equals X, okay? Why? Because the examiner said that this QN bisects, okay? So, why are these equal to each other? Because the examiner told us that this is given. Okay, it was given by the examiner that QN bisects the angle MNP. So this QN bisects MNP. Now, moreover, if you look very carefully, the angle P3, this one is forming a butterfly, this. It's a bow tie. It's a bow tie this, so that this angle is equal to this. In other words, we're able to see that angle P3 is equal to x. Is equal to x. Or you can say, okay, you can say that angle P3 is equal to N1. The angle P3 is equal to N1 because they like bow tie angles, and then P3 is equal to N1, but this N1 is equal to x, so that P3 itself is equal to x. And the reason for this is you have angles in the same segment. Angles in same segment. Like this. So that in the end, then right now, okay, you have this one is x and this one is x. Okay, now P3 equals Q2. Okay, so in other words, what have we been able to establish so far? We've been able to establish that indeed P3 is equal to x. So, but this Q2 is equal to x. So we have this triangle here that is isosceles. So if the base angles are equal, it means the sides opposite the base angles are also equal in length. And therefore, it therefore means that we can make the conclusion that therefore the angle P3, yeah, I can write, angle P3 is equal to the angle Q2. So we've seen that the angle P3 is equal to Q2. And because they are both equal to x. Why is the angle P3 equal to Q2? They are both equal to x. This one is x and that one is x. So that's why they're equal to each other, these angles. Okay. And then now, because this one is equal to this one, we come back and we look at what we're having. From the proportionality theorem, the examiner wants us to prove that we have Mn and R, then we have Ms in the numerator. We just have to deal with the SP and the SQ here. That's all. Okay. And then we come here to say, Mr. Examiner, therefore, from this, the fact that this is equal to this, it means that this side is equal to this side. And therefore, it means that SQ is equal to SP. Okay? SQ is equal to SP. Why? Which are sides opposite equal angles. Okay, these ones, the SQ and the SP, they're sides opposite equal angles, these. Okay? All right, now we're in business. What is all this now? And what do we conclude now? The conclusion is very easy, very, very straightforward. Right, we're able to see and say, Mr. Examiner, we are very thrilled, but very delighted to say, therefore, Mn over Nr, okay, we're copying this one. Therefore, Mn over Nr is equal to Ms over this SP is equal to SQ. So in the place of SP, we can put SQ. And this is exactly what the examiner has, right? Mn over Nr is Ms over SQ. And this is it. And then we're done. Okay, we've proven this one. And this is awesome. These are the things you're going to meet in the exam, guys. So you need to take them very seriously. I'm not just proving these things like this, but I'm trying to open your heads. I'm trying to open your minds so that you can deal with geometry. There are many things in mathematics and science that we're here to do, but your minds must be open. Your eyes also must be open. Let's look at the next question. Right, the next question is very similar, particular that we've already seen. Right, so in the diagram, a circle, right, here's the diagram. A circle passes through D, B, and E. D, B, and E. And this circle passes through D, B, and E. Here's the circle. It passes through this. Right, there's a diameter ED. Right, so a diameter ED of the circle is produced to C. And AC is a tangent to the circle at B. AB, or rather AC is the tangent to the second piece. So we're dealing with a tangent here. This one is a tangent, so we'll see all the good things. But diameter ED, the fact that from E to D, ED is the diameter, it means that the diameter must attend an angle of 90 degrees. So here is the diameter, and it makes an angle here. So this angle here is exactly 90 degrees already, because it is an angle in semicircle. Okay, and then what else? And then we have this. Oh, this is awesome news. Right, so now we already have this. This is, now they're asking us to say, okay, now there are a couple of things here produced to see. AC is the tangent, there it be. M is a point on DE. Here's M, that is a point on DE. Right, such that AM is perpendicular to DE. Right, so you have that AM is perpendicular to DE. AM and chord BE intersect at F. So you have AM and the chord BE, they intersect at F. Here is F. F now is having parts 1, 2, 3, 4. Right. Now proof giving reasons that FBDM is a cyclic quadrilateral. Right. FBDM is a cyclic quadrilateral. Okay. So good. There are many ways to prove this, but let's just use one, just one. So we're going to look at 10.1.1. Now, this one you can already see. This one is 90 degrees. This one is 90 degrees. The exterior angle of a cyclic quad is already the interior opposite angle. And then you're done. So, okay. You can always do that already. And then, but there are a couple of ways that you can use, very popular. You can just start by saying DBE. Right, angle DBE. Angle DBE. Angle DBE is equal to 90 degrees, which is an angle in semicircle. Angle in semicircle. Okay, the fact that this angle here, DBE, is 90 degrees, we stated that is an angle in semicircle because I just marked it. But now angle DMA, call it that. Right, DMA. Okay, the angle DMA is equal to 90 degrees. Why is angle DMA equal to 90 degrees? It is 90 degrees because of the fact that this AM is perpendicular to what? To DE. AM is perpendicular to DE. Therefore, okay. Therefore, now we already have that this one is, the DMA is 90 degrees. So this one is 90 degrees. You have 90 degrees, 90 degrees. 90 degrees and 90 degrees, if you add them up. So therefore, the DBE plus DMA is equal to 180 degrees. And, okay, that's fine, because we just added up 90 plus 90. 90 plus 90 is 180. So adding these two angles up, DBE plus DMA is 90 plus 90, which is 180 degrees. So, yeah, we're happy. We're happy with that. Next, what do we then do next? Do the following. So we say, therefore, FBDM is a cyclic. It's a cyclic quadrilateral. It's a cyclic quadrilateral. Why is it a cyclic quadrilateral? The reason is converse. Converse opposite angles, cyclic quad. Converse opposite angles, Converse opposite angles, cyclic. Cyclic quad. Right, converse opposite angles, cyclic quad. So this is what we have. Right, so this is what we got. So in other words, we've been able to show that this first part, FBDM, is a cyclic quadrilateral. Why? Because if you look at the fact that FBDM is a cyclic quadrilateral, because these opposite angles here add up to 180 degrees. So the opposite angles are supplementary. So we have been able to prove this one. Okay, I've already sent you a homework, so you need to start doing that homework. And then I'm going to send you other homeworks. You have the whole week to do the homework because I know that you are busy with many subjects. You're not only doing mathematics and science, and I must think for you. I must feel the pain for you. Now, the next thing, we must prove that B3 is F1. Angle B3 is this one. You must prove that this angle B3 is equals to, this is F. So you must prove that it is F1. B3 is equal to F1. How do we therefore prove this? Okay, so this is very, very easy. Let us proceed to prove that. So to prove that now, we are looking at 10.1.2. And want to prove that the angle B3 is equal to F1. Is equal to F1. The question is, how do we prove that B3 is equal to F1? How do we prove this? So we proceed to prove these things as follows. Let us prove this together. Right, to start with, what can you say? Because already we know something. I mean, we already know about the fact that the angle B3 itself is related to the angle D2. Because this one is a tangent to this. And then we know that if there's a tangent, then we know that there's a triangle like this. There's a triangle like this. We look at the angle between a tangent to a second and a chord equals the one in the alternate segment. Right, so that angle B3 is equal to angle D2. Angle B3 is equal to angle D2, which means that you have the tan chord. Right, and then you can say it is, you can even say it is the tangent chord theorem. Tangent chord theorem. So that this B3 is equal to D2. Right, and then now you have F1 is equal to D2. You have F1 is equal to D2 because you already have the exterior angle of a cyclic quad. Because now if you already have a cyclic quad, you prove that this FBDM. Okay, if this FBDM is a cyclic quad, FBDM is a cyclic quad like this. Okay, now this is not clear. Right, so, okay, you're dealing with a cyclic quad, and we're remembering from grade 11 what the cyclic quad is doing. So this angle is equal to that angle. Okay, we say the exterior angle of a cyclic quad equals the interior opposite angle. Okay, so now at this point, we then say B3 is equal to D2. Well, that is the tan chord theorem. And then next we have because we already know that FBDM is a cyclic quad, so that angle F1 is actually equal to angle D2. So angle F1 is equal to the angle that sits like here. So F1 is equal to the angle D2. Why is this? Exterior angle of cyclic quad. Exterior angle of cyclic quad. Okay, but now we have B3 is D2, F1 is D2, and therefore it means that B3 is equal to angle F1. It means therefore that B3 is equal to angle what? Is equal to angle F1. Right, and this is what you're supposed to prove here, that B3 is equal to F1. So this is 10.1.2, and we've proven that B3 is equal to F1, so that when we're here, we can say this B3 is equal to F1. They're equal to each other. This angle is equal to that angle. We've proven through the steps there. Okay, the next thing, and which is the last part for the 10.1 part, is to show that this triangle CDB, is to want to show that triangle CDB is actually similar to triangles. So we're looking at the similarity of triangles. Right, and looking at triangle similarity, we're looking at the answer to 10.1.3. Right, so the answer to 10.1.3 proceeds as follows. How do we therefore prove this? We're going to prove this one in a couple of ways, but how so? In a couple of ways to prove this. Right, then we're going to say in triangle. Right, so yeah. Tell the examiner in triangle CDB and triangle CBE. And then now, okay, let's look at the triangle CBD. CBD. And triangle CBE. 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 And then CBD. Hey, we want 100% in mathematics from you guys, but you must listen attentively to get the 100% because we cannot accept anything less than 100% from you guys in the finals, but also in the June exams that are coming, like next month in May. So yeah, we need hard work. So now we are then saying, if you look at the fact that now we're looking at the triangle CDB, and the triangle CBE, what do we need to actually, what do we know here? Is that these triangles, they share this side C, this angle C, because the CDB and CBE, they have the same angle C. In other words, we can say therefore that if you want, you can draw the triangles like this. You can draw like this, okay? And then do CDB 1. And then also do this, right? And then do CBE, right? And realize therefore that this angle is equal to this angle there, which means that angle C is equal to angle C. What is angle C equals angle C? And this is a common angle. Common angle. Right, so that now in the end, then you have angle CBD. Angle CBD is equals to angle CEB. Okay, watch that one. So this angle here, CBD, this one, is equal to CEB, this one, because it's dealing with a tangent here, so we have the chord theorem property. So yeah, CBD is equal to CEB. Right, it's equal to CEB. Why is this the case? You have the tangent chord theorem. Right, so we have this and that. And then now you already mentioned like two angles. You've already mentioned this one, the C and the C, but we have also mentioned that the B is equal to the E. So you're left with the angle CDB. We are left with this one, and here we are left with CBE. So we then say that the third point is to say that the angle CDB, the angle CDB is equal to the angle CBE. Angle CBE, which is the angle sum in triangle. Angle sum in triangle, and therefore triangle CDB is similar to triangle CBE. Why? Why are these triangles similar? Angle, angle, angle. Angle, angle, angle. Okay? So this is what we have. So we've been able to prove that these two triangles are similar to each other. So to prove that two triangles are similar, we need to prove that the two triangles are equiangular. So you need to prove that the corresponding angles of the triangles are equal there. Okay, next point. So if anyone has a question, you need to ask, because you need to understand all these things. I'm not just doing these things. I'm doing these things to demonstrate to you how these questions must be answered in the exam. It's not that we're just doing this for fun, or we're just doing this to pass time. No, we want to get distinctions from you. We want 100%. But to get 100%, we must practice. We must train you so that you can be able to do these things. Right. So now we look at the next question that is asked in geometry. Right. The next question that's asked in geometry is to say, okay, the story above is the same. We read everything here, and we've been able to prove a lot of the previous results. But if it is further given that CD is 2 units, CD, here is C and here is D, is 2 units, and DE, right, from D here to E here is 6 units. Okay, DE is 6 units. Note that. So if this one here is exactly 6 units, calculate the length of BE. Find the length of BE. Or rather BC. Find the length of BC. So we're looking at 10.2.1. Want to find the length of BC. How do you find the length of BC? Right, to find the length of BC, there are a couple of things that remain very, very important for us. Let us do this. Right, to find the length of BC, we go back to the triangles that we have just established now. We established that triangle CDB, so we write that one down. Triangle CDB is similar to triangle CBE. CBE. Why? This one has been proved in 10.1.3. Proved in 10.1.3. And then now, because this has been proved, you can do what I said last time. These angles are in the right order. C equals C, D equals B, B equals E. So that you can take the first two like this, the next two like this, and then the first and the last, the first and the last. Okay, so you come here and then say, you take CB, let's take the first. So CD, right, to write all of them, all the three ratios. So you have CD over CB is equal to DB over BE is equal to CB over CE. Okay, so now, and this is a conclusion. These are similar, and then this follows from the proportionality theorem. Okay, then now we're gonna continue with this. So we need to choose, we need to remove one thing here that is not gonna be very useful. So let us see what we're gonna do. Right, so we can consider a couple of things. Right, for example, we can consider this one, and then consider this one, and then let's see, we can also consider this one here. Right, so let us think very, very carefully. Right, so if you consider this one with the DC, and we consider the CE, and then we remove this one. Okay, that's okay. Okay, you will see why. And then now we have CD over. This one you can write it as BC. And this one you can write it as CB, but you can write it as BC for the sake of this. And then now we have CE. Okay, now BC times BC is BC squared. Is equal to CD times CE. So what is CD? What is the CD? Right, so CD is 2 times. What is CE? Right, CD is 2. And then what is CE? Right, CE. CE is 2 plus 6, which is 8. And then what is 2 times 8? It's 16. Okay, as a conclusion with that, BC squared is 16. Okay, if BC squared is 16, it means that we can take the square root of BC squared. And this, we take the square root of 16, which is BC equals, what is the square root of 16? It is 4 units. So BC is 4 units. Right, so that's what we have. Right, so we have actually answered this question, and we have found BC because they said calculate the length of BC. This is how we must find BC. So now this is B here, and this is C, and we can see that it is exactly what? It is exactly 4 units there. Okay, so we have, so any question, who has a question, who does not understand how we have proven this, who is confused here, who is not sure of why we did these things that we've done, somebody can just look at this and be like, this thing is Greek. Okay, so first things first, to write these ratios here and the proportions, you need to make sure that first you have similar triangles. And how do you achieve these similar triangles? These similar triangles, you achieve this from equiangularity. So the triangles that are equiangular are triangles that are similar. And if the triangles are similar, then the corresponding sides are in the same proportion. Okay, and so these are the kinds of things that you need to learn, but also that you need to master so that you become a mathematician, but also so that you get the 100%, because we need 100%. I want 100% from Tando. I want 100% from Nombuso. I want 100% from Tsenulo. Okay, because those are the guys that are online now. I have other students. Some other students could not join, but I also want 100% from them, because guys, we can't settle for anything less than 100%. We can't settle for 99. We want 100 full marks. That's what we want. Let's look at the next question. Right, so obviously if it is further given that the CD is this, but you already know BC is 4, you already know that CD is actually 2, you already know that DC, right, DE, excuse, now DE, this one here, DE is 6. So we want to calculate the length of DB. So you have 10.2.2. Okay, now we're gonna start from the things we actually the similar triangles that we got. So we have triangle CDB. CDB is similar to triangle. Okay, check the other one. CBE. Okay, look, these are similar. Why? Because it was proved above. Okay, we proved that these triangles are what? We proved that these triangles are similar. So that CD over, now you take the first two, and then you take CB, which is the first two, then you take DB, the last two, and then you take BE, the last two, and then take the first and the last. CB, you take the first and the last. CE, like this. Right. So we have DB over BE. Okay, which is the middle part. And then you equate it to BC. Okay, you can call this BC over CE. So we've taken the middle part, but you're also taken the last part. So yeah, it follows. that way. So that what is BC? This is 4 over CE is 8, which is 1/2. And then now, which is DB over BE, which is 1/2. So you cross multiply this, which means that it is BE, which is BE is 2 times DB. So which then means that, okay, you have this one, but let us do in red now. We can use Pythagoras theorem in red. Right, Pythagoras theorem in red. Let us try to use that part. So we are dealing with so we can look at this triangle. We can look at this triangle here. This one. So we can tell the examiner that in triangle, check this one, triangle DBE. Triangle DBE. What do we have in these triangles? We can, this one is a diameter. So D is a diameter, so it subtends an angle of 90 degrees there. So Pythagoras theorem is very clear that you square the hypotenuse. The hypotenuse of a triangle is the longest side of the triangle that is opposite the angle of 90 degrees, so that you have that D squared is equal to the sum of the squares. Okay, so D squared is equal to DB squared plus BE squared. Why? Because this one is Pythag. Right, so what is this? All right, so now we have DE. And then what is the DB? And then what is BE? BE is 2 times DB. Like this. Okay, which means that DE squared is the DB squared plus 4 DB squared, which is 5 DB squared, which is 5 DB squared. What is this? So what you're then having here, you're having that DE squared is equal to 5 DB squared. What is DE squared? Which is 6 squared is equal to 5 DB squared. Which means you have 6 squared out of 5. 6 squared out of 5 is DB squared. And then you take the square root on the left, you take the square root on the right. And the conclusion is therefore that DB right, DB. And then now you take the square root of 6 of the, you can write, this one is 6 squared, but yeah, you can write it like that. What is 6 squared? Okay. 6 squared is 36. You can write 36 here. You can write 36 because 6 squared is 36. Then divide the square root. What is square root of 36? It is 6 divided by the square root of 5. Which is 6 divided by the square root of 5. And therefore, as a consequence, then it is DB. DB is approximately, now it is 6 over the square root of 5. 6 out of the square root of 5 is 2,68 units. Okay, we can come here now and then, yeah. So anyway, it's clear that DB is 6 over the square root of 5. 6 over the square root of 5, which is 2,68 units. All right. And so, yeah, we've gone through this discussion, and this was the last bit. I feel like maybe we can do something small. Okay, this was the part B, the DB part. So we found BD, DB, but we also found BC. Okay, at your school, the teachers will start doing this topic here. They will start doing this topic. Right, so they'll start doing these triangles. So it's very important that you have a firm understanding of the triangles. Now let us look at the triangles. Like triangle TSK is drawn. T is this one, okay? And then S is this one, and K is this one. So triangle TSK is drawn. The equation of ST is y equals 1/2 x plus 6. Right, so in other words, if you were to look at ST, the equation of this one is y equals 1/2 x plus 6. And ST cuts the x-axis at M. ST cuts the x-axis at M. Right, W has the coordinates -4 and what? -4 and 4. Okay, -4 and 4 there. So let us continue quickly because I want us to solve some of these questions. That's why you can have a feel. Okay, this section is called analytical. So we're starting analytical geometry. And I'm going to send you some projects for you to start working on so that you can familiarize yourself with this one. So that when your teacher gets to this point, you are not in trouble. You are not very much confused, but instead you're good. So the examiner is then, okay, yeah, so you have all these. And this W lies on ST. W lies on what? On ST. And R lies on SK. R lies on SK. And WR is parallel to the y-axis. WR is parallel to the y-axis. WK cuts the x-axis at V. WK, this one, cuts the x-axis at V, and the y-axis at P. KS produced. Okay? KS produced, right? There's K is K, and here is S. So KS produced cuts the x-axis at N. You can see N here. Right, so the angle TSK is theta. Right, we have the angle TSK. This angle is what? Is theta. Calculate the gradient of WP. Want the gradient of what? Of a WP. What is the gradient of WP? To find the gradient of WP, so we start like this. First, we must draw the WP. So you must draw, you can draw a small thing here. Right, you can draw a small thing like this. Okay. Which is x1, y1, x2, y2. y2 minus y1 over x2 minus x1. What is y2? It is -4 minus y1. x2 is 0. What is x1? This you saw in grade 10. You saw in grade 10, this gradient. It's grade 10 work. And then if you add these things, you get -8 over 4, which is -2. And therefore, the gradient of WP. So the gradient of WP is what? Is -2. So you have, therefore, that the gradient of WP, because we have to find the gradient of WP. What is the gradient of WP? It is -2. The gradient formula is change in y, change in x. Is delta y, delta x. And this delta y is y2 minus y1. The delta x is x2 minus x1. And then now, because we're dealing with WP, so we're moving from W to P. The coordinates of W are called x1, y1. The coordinates of of P are called x2, y2. And we substitute everything because the y2 here, we put -4. The y1, we put a 1. The x2, we put a 0. The x1, we put a -4 there. And the answer becomes -2. Next question. We need to show that in the next part, we need to show that WP is perpendicular to ST. So to show that WP is perpendicular to ST, what is the gradient of ST? The equation of ST is this one. And now, if you look at this very carefully, the fact that it is this equation of ST is 1/2 x, it means that the gradient of ST is this one, is 1/2. Okay, if you have that, y is 1/2 x plus 6, so the gradient of ST is what? Is 1/2. Okay, the gradient of WP, the gradient of WP is -2, like this. So now, in the end, it then comes and you say that's the gradient of WP multiplied by the gradient of ST. What is the gradient of WP? It is -2 times the gradient of ST. It is 1/2, which is -1. So that in the end, we have ST is perpendicular to WP. ST is perpendicular to WP. Right, so obviously now, or you can then say ST is perpendicular to WP, or you can come here and say, WP is perpendicular to ST. How do we know that the two lines are perpendicular? These lines are perpendicular, so that you can say the WP here is W and here is P. This WP is perpendicular to ST, so that this angle is how many degrees? Is 90 degrees there. Why? It is 90 degrees because the product of the gradients is equal to -1. If the equation of SK is given by this, calculate the coordinates of S. Calculate the coordinates of S. If the equation of SK is given by this, calculate the coordinates of S. So we can easily find, let us find the coordinates of S. So to find the coordinates of S, we proceed as follows. Let us get this one quickly. Okay, this lesson is being recorded, so these things, even if you don't, you're gonna have them. But now you need to write them in your book. You need a book that is gonna be separated from this. This is not a movie. You don't just watch these things and then stop there. When you get home, you practice, you do everything here. Okay, let's do this. Okay, now equation of ST. Right, so you have the equation of ST, which is y equals 1/2 x plus 6 in the equation. The equation of SK is 5y plus 2x plus 6 equals 0. and calculate the coordinates of S. We want to find the coordinates of S. Now, in other words, in this exam question, S is this one and K is this. This is S and this is K. So you have this, if this is S and this is K, we're already preparing you for the June exam, guys. This is WO. This SK as the equation this. And then now we have the equation of ST, which is this one, 1/2 x plus 6. So these two lines here, this one and this, they meet here, they intersect. So you need to find the point of intersection. Point of intersection. How do you find the point of intersection? You perform a substitution. To find the point of intersection, you put ST into SK. You put ST into SK. So you put this ST into SK. So you have 5. The Y here is 1/2 x plus 6 plus 2x plus 60 is 0. Okay, you multiply these things. 30. 2x plus 60. And then which is 5 over 2x plus this, which is 9x over 2, which is minus 90. 30 and 60 is minus 90. We need to solve for x here. How do you solve for x? How do you solve for x here? So to solve for x here, you can cross multiply. Then x is 2 times minus 90 is minus 180. You divide by 9 so that minus 180, you divide by 9, and this is what? Minus 20. Right, you can use any of those equations. You can use this one, for example, or this one. So you have y equals, okay, this is 1/2 x plus 6. Okay, because these are simultaneous equations, you are finding a point of intersection, so you must substitute into one of the equations to get the y. So this one is easier because y is already the subject of the formula. And then you have 1/2. The x is minus 20 plus 6. What is minus 20 plus 6? Is minus 10 plus 6. What is minus 10 plus 6? It's minus 4. Obviously, in the process, we want to get the coordinates of S. And the coordinates of S, the coordinates of S are x equals what? Minus 20, and y equals minus 4. X equals minus 20 and y equals minus 4. And that is the answer. Okay, because the question said determine the coordinates of S. And these are the coordinates of S, minus 20 and minus 4. Right. We have come to the end of our discussion for today. I'm going to post exercises on the group, on the WhatsApp group. I'm going to, you need to send them during the week to me. And then I'm going to mark and I'm going to allocate marks for you. Okay, for the things like today, I send you some activities. Please do those activities, and then you send me pictures of your answers. You don't send your answers on the WhatsApp group for people to see your answers. You send them directly to me, and then I'm gonna mark them, and then I'm gonna send you the marked scripts, and then I'm gonna record your marks so that I can see your progress and see if you are making sense of these things. And then I'm gonna also send more physics because we're gonna do more physics and chemistry this coming week. Right, and from us, thanks a lot, guys, for joining us, and have a good evening and good night. Right, good night. Good night.